Okay, everybody. Polynomials lesson number 1, brand new unit, so it kind of matches up perfectly with starting an online class. We are on page 288, starting with polynomials. This is the general form of a polynomial. You obviously do not need to know that. You would be used to seeing things written like this. Something like that. um, so if we move down, we have this polynomial here. F of x is equal to x to the 4 plus 7x cubed minus 8x squared plus 5. So when we're talking about the degree of a polynomial, we're always talking about the highest exponent there is. And in this case, it would be 4. So the degree of this polynomial is a 4. Leading coefficient is the number in front, ignore that, is the number in front of the term with the highest exponent. So in this case, there would be a 1 there. The leading coefficient is a 1. Constant term is the term that has no variable. In this case, that would be 5. All right. Defining a polynomial. So anything that has roots of variables, so that is anything that looks like that, root x, whether it's a cube root or a square root or whatever. Negative or fractional powers, so x to the minus 1 being that, or x to the 1/2. Again, this 1/2 would be a square root, or any coefficient that is non-real, i.e. you cannot square root a negative number. They are not polynomials. So looking at these questions down here, which of the following would be a polynomial, or just say if they are a polynomial or not. The first one here, we have a fractional exponent, so not polynomial. The second one, B, we have a negative exponent, not polynomial. Third one, that's good, that's good, that's good. This one, we have a square root of 17, that's fine. You can square root 17, you just cannot square root negative numbers. So this is a polynomial. This, however, is not, because this is a square root. And remember, root 5 is fine, but this x would become x to the 3/2. So that violates. So that is not. This one here, it looks like this doesn't, but remember that's a square root. So we get root 3, which is fine, but we get x to the power of 2 over 2, which is actually x to the 1. So that would become root 3x. So this is a poly. And this one here, cube root of 3, that's fine. X cubed is fine, but cube or square root of a negative number can't do. So this is not a polynomial. All right, flipping the page. State the degree, the leading coefficient, and the constant term. Okay, so start out the degree. Highest exponent. This is a 3, so it has a degree of 3. The leading coefficient is the number in front of the term with the highest exponent. In this case, that would be negative 25. Always take the sign that is in front of the number. And the constant term, again, the one with no variable, in this case, negative 39. Always take the sign that's in front. B, now it's not multiplied out, but the degree is fairly straightforward. All you have to do is look at the x terms. That's x, there's a 1 there. That's x to the 1. So that is like x to the 1 times x to the 1, which would be x squared. So the degree is 2. Leading coefficient is the numbers in front of those terms. So all you really need to do is take the number in front of this x, raise it to that power, 5 to the 1 times, the are being multiplied, 2 to the 1, which is just 5 times 2, which is 10. Leading coefficient is 10. Constant term, again, same thing. You take these n numbers here, negative 1 times negative 7, or times 7, is negative 7. That's your constant term. And if you multiply that out, you would get that. All right, a little more complicated, but still, we're looking at the degree. So take this x is being squared. So that's an x squared times this x squared, that is to the power of 1. X squared times x squared is x to the 4. Leading coefficient, again, but you multiply these numbers, but you're going to have to account for the 2. So you take the 2, this 3, change colors here. This 3 here is being raised to the power of 2 times this 5 is being raised to the power of 1. 3 squared is 9, times 2 is 18. 18 times 5 is 90. And if you expand that out, you would get 90 as your leading coefficient. The constant term, you guys are going to like all my different colors I get to use here. The constant term, again, this number in front, the 2 has to be accounted for, so it's 2. This negative 1, which is squared, and then this 1 here, which is raised to the power of 1. Negative 1 squared is just 1. 1 times 1 is 1. 1 times 2 is 2. So your constant term is 2. And if you, in fact, you expand this polynomial out, I'm not going to do the whole thing, but if you did, because what this really means is 3x minus 1 times 3x minus 1 times, I'm going to run out of room. If you multiply all that out, you would get 90x to the 4th minus 78x cubed plus 40x squared minus 14 plus 2. Constant term, leading coefficient, degree, right there. Okay, this one, again, degree. So we care about this x here, raised to the power of 2, plus this x squared, raised to the power of 1. If you add those together, all we really care about is we're looking at the exponents. The exponents don't change. So the degree is going to be something x squared, which is going to be 2 is your degree. All right, so now we're going to do the leading coefficient. So the 2 times 3 raised to the power of 2 plus 5x squared, and that's raised to the power of 1. That should have an x there. So 3x squared is going to be 9x to the 9x squared. 2 times 9x squared plus 5 squared, which you can't see, which is going to be 18x squared plus 5x squared, 23x squared. So you can see the degree is 2, which we stated in the first part. The leading coefficient would be 23. The constant term, which we'll do in red, constant term is going to be 2 times negative 1 squared plus 1 to the power of 1. Negative 1 squared is 1 times 2. 2 plus 1 is 3. So bottom of the page here, there's the polynomial function p of x is equal to 7. Explain why the polynomial function p of x equals 7 has a degree of 0. Well, I could write it like this. P of x is equal to 7x to the 0. Because anything to the 0 power is equal to 1. So that is equal to 7 times 1. It's just 7. And you can see the degree is 0. Why is this type of function called a constant function? It has no variable. Therefore, it doesn't change. All right, so this is where in class I would stop and assign some questions. The questions you should do at this point are numbers 1, 2, and 3. Take your time. I'm just going to continue. You can just pause the video. You can just, and then move on to the next bit. Page 280, 289 we're not doing, so just skip that. Go to page 290. Again, we're not doing that. So we're doing these last two questions here. P of x, P just means a polynomial. That's why they use that instead of f that you're used to seeing. Equals negative 3x squared plus ax plus 8. P of 1, remember whatever's in the brackets is your x value, and that is your y value. So when your x value is 1, your y value is negative 9. Find the value of a. Well, put in 1 for your x's, put in 9 for your y, because remember this is the same as y equals all that. So if we put negative 9 is equal to negative 3, 1 squared, whatever you sub in, put it in brackets, please. You get that. Negative 9 is equal to negative 3 plus a times 1 is a plus 8. Negative 3 plus 8 is 5. Move the 5 over. Negative 14 is equal to a. That's a pretty standard question. If we were in class, that would be guaranteed to be a quiz/test question. All right, moving to the next bit here. Slightly more complicated. We have two unknowns, a and b, in this polynomial, but they give us two pieces of information. They tell us when x is equal to 2, y is 18, when x is equal to negative 3, y is equal to 30. So you deal with one piece first. Again, in for x's, in for y's. So negative 8, negative 8. Why is my pen not working? Negative 18 is equal to negative 2 squared plus a times 2 plus b. We don't know what b is. So we're going to simplify this as far as we can. Negative 18 is equal to negative 2. 2 squared is 4 plus 2a plus b. So negative 18 is equal to negative 8 plus 2a plus b. Move the 8 over. I get negative 10 is equal to 2a plus b. Can't go any further than that on that equation. So I'm going to change colors here. Then we're going to do this. Put in negative 3 for x and negative 13 for y. A times negative 3 plus b. Again, simplify as far as you can. Negative 3 squared is 9. 9 times negative 2 is negative 18. Minus 3a plus b. Move the 18 over. 18 plus 13 is 5. Sorry, negative 13 plus 18 is going to be 5. It's equal to negative 3a plus b. Okay. Now what we've done is we've created two separate equations, each with two unknowns. And if you have two unknowns, you need two equations to solve it. If you have three unknowns, you need three equations to solve it. So you have a choice here. I'm going to show you two different ways to do this. First way is we're going to do a substitution. All right, so I'll change colors again. Green. We're going to solve for one of these variables. It doesn't matter which equation you do it in. I'm just going to use the purple one here. I'm going to solve for b because it has a coefficient of 1, which makes it easier. All I do is move the 2a over. So if I move the 2a over, I get this. b is equal to negative 10 minus 2a. Then that gets subbed into that b right there because that's what b is. So this is going to generate a new equation, 5 negative 3a plus, and instead of b, I write all of this. And I'm going to put it in brackets. You don't need to because it's positive, but when it's negative, it will matter. So it's just a good habit to get into here. I get that. Now I have one equation and I have one unknown a because I can combine those. So we simplify this. Negative 3 is that. Negative 3a minus 2a is negative 5a, and that is negative 10. Now I gotta solve for 5a. So I'm just gonna move the negative 10 over and get 15 is equal to negative 5a. We'll then divide by negative 5, and I get negative 3 is equal to a. All right. Once you know a, you can solve for b. So how am I going to do that? I'm going to put that right there into that a, and I'll spit out b. You could put it here in that a there, excuse me, and solve for b. It doesn't matter. So negative 10 minus 2, instead of writing a, negative 3 is b. Negative 10 plus 6 is equal to b. B is negative 4. And there's your two answers. A is negative 3, b is negative 4. There is another way to do it. I will fit it in here. And that is, if you remember your grade 10 math, adding and subtracting equations, we use these two equations here. And we go, okay, negative 10 equal to 2a plus b. And I take the other one, 5 is equal to negative 3a plus b. It's important that the constant terms line up, the a's line up, and the b's line up. I want something to cancel. I want the b's to cancel. So what I'm going to do is I'm going to subtract them. Okay, and if you subtract them, negative 10 minus 5 is negative 15. 2a minus negative 3a, which is 2a plus 3a, equals 5a. b minus b is no b's. Divide off the 5, and you get negative 3 is equal to a. So same thing, and then to find the other one, you'd just plug it into one of these equations. Your choice. All right. The online, or the questions I would like you to do are numbers 4, 6, and 7. That's a very short video. This is just an introduction to the unit. I will post another video probably later today or tomorrow that again is fairly short. But I hope this all works out, and email me if you have any questions. Thanks.